Hello! Today you and I are starting to study the next section of physics, which is called dynamics. And of course, the basic laws that we will be using in this section of physics will be Newton's laws. Today we're going to learn Newton's first law, which allows us to understand how a body can either remain at rest or move in a uniform straight line, and what conditions must be met for that to happen. And we'll be introduced to a new concept that is a central concept in the framework of this chapter of physics. This concept is called force. What is force? You and I encounter this concept every day. And in order to describe many of the processes that occur around us, we have to use this concept. Force we call some physical quantity that will show how these bodies are interacting. That is how intense the interaction is, where it's directed. What is the result of this interaction? All this will describe the force action between bodies. We call a force a quantity that is denoted by the letter F, so it naturally has its own symbol. And it naturally has its own unit of measurement. Force is measured in newtons. This unit of measurement is named after a scientist who made a great contribution to this section and Newton's laws. These are the basic laws of classical mechanics. What happens when a force acts on a body? Well, there are different effects, of course, but first of all we have to talk about two basic parameters. These are the magnitude of the force and its direction. Force is a vector quantity, so it has a direction, and in the drawings that we're going to make, we have to show where the force is directed. The solution of the problem will depend on it. In the drawing, we can show the action of the force in this way. Suppose we have some object that is on some surface. We can look at it either from the side or from above. In general, foreshortening can play a role just for convenience. Suppose we are looking at a certain box located on a table, and this is a top view. So it's some kind of table. And in some direction, for example, in this direction some force starts to act. That is, we, for example, start pushing this box. As a result of this action, the box starts to move. Again, how it will move will depend on a number of conditions, but nevertheless its state will change. And so it's our job to show you exactly what happens as a result of this force, what the motion of the box will be, and to study the laws of motion. And on this diagram, we show the action of this force like this. Let's write down the unit of measurement. What is the unit of measurement of force? Once again, force is measured in newtons. How a given force will be written out through the basic units of C, we'll get to know a little later. So what is Newton's first law now? Well, you and I often find ourselves in a situation where a body is at rest or moving in a uniformly straight line. And it's our job to understand why that motion occurs, or why that state of motion. This state of motion is occurring. So, the main reason for this state of motion is that, first of all, there may be no forces acting on the body. Well, in our world, because there's always something acting on the body. Or another similar effect occurs if there are forces acting on the body which begin to compensate each other. For example, if you're sitting at a table right now, there are many forces acting on you. Naturally, the first of these is the attraction to the Earth, which keeps us on this planet. But why don't we then fall to the surface of the Earth? In this case, we are kept from falling by many objects. For example, the chair that you're sitting on, the table on which you could rest your arms, or the floor, which is actually where all the objects are. And in this case, the sum total of all these forces acting on you is zero. As a result of this, we observe a state of rest. That is, the velocity of the body is zero. But you and I know very well that speed is a relative concept. And of course, here we need to realize that in different reporting systems we can observe different manifestations of these processes. So, here it is very important to mention that we can apply this format of explanation only to special frames of reference, which are called inertial frames of reference. We meet here with a new concept which is called inertia. This concept shows us that a body can either be at rest or moving in a uniformly straight line. Basically, we can describe it as either the absence of velocity or it's constant. provided that the force acting on the body is 0, or the sum of all the forces. If there's more than one, in this case we speak of a vector sum, will also be 0. So in both of those cases we get this effect. And when we solve a problem with you on this subject, we have to realize that there can be many forces acting on a body. But the most important thing is to show the sum total of the forces that are going to create this effect. So if the body is moving uniformly in your problem, we need to look at the pattern of forces that will occur in this situation. Let's say we can consider, again within the framework, the motion of this box on some horizontal surface under the action of some forces. Let's say we're pushing this box in this direction. So there's a force, our force, and we are pushing it. And if the velocity of this box remains constant and pointing to the right, it's because there's some other force acting against our force that's completely compensating for it. So there's some force acting in the opposite direction. Let's say our force, let's say it's F1. There's a certain force F2. You and I will also learn about its nature a little later. And so we can say that the sum of these two forces, the vector sum of these forces is 0. The result of this motion will depend on that. Actually, in inertial reference systems, which are those systems that are standing still or moving in a uniformly straight line, this law will be satisfied. If the system itself has acceleration, that is, you're in an elevator that's going up with acceleration, or you're in an airplane that's going up with acceleration, you're in an airplane that's taking off from a landing strip, then the system itself is not inertial. And in that system, these laws no longer apply. Therefore, when solving problems, we must take into account in what system of report you are in and how this system will affect the methodology of solving the problem. So we've seen how Newton's first law works in different situations. Got acquainted with the new concept of inertia, introduced a new concept of force with which we will further work in more detail. Our task will be to find out what kinds of forces exist in nature and what other traffic cases can be found. If we talk about the action of several forces on one, this is the end of our lesson. See you in the next lessons. Goodbye.